Classroom example number 1 from section 5.1. This is just plug in the number that they give you and give the answer. All right, so let's do that. Let's have someone do A. Plug in 5. What do you get when you plug in 5? 4.753 times 0.9421 to the 5th. What do you get? Should you get more or less than the start value? You should get less because it's decaying. What'd you get, Ian? Okay. Let's do 5296. That's fine. Okay? So you're just plugging in the number and you see what you get. I don't think we need to do too many examples on that. All right? When we do these problems tomorrow in class, when we talk about the green worksheet, I may ask you to give me an example of what this problem might represent. For example, this might be a radioactive decay problem where you start with 4.753 grams of something, and it's losing its amount by what percent? What percent would it be losing? If it's retaining 0.9421, what percent is it losing? How do we do that? 5? 5.79. Come on, here's how we do this. Yeah, you're doing it right. You take 100 minus 94.21. All right? You just consider how far below 100% is your decay factor, is your ratio, right? If it's, you used the word before, retaining. If it's retaining 94.2%, what percent is it losing? Or on a test, if you got a 94%, what percent did you lose? 5.796%, okay? So 5.79%. Okay? Write 3 terms of the sequence and write the explicit formula. Let's do 2A together. Ready? What does it start with? 16. What's the next number if you retain 75%? 12. 9. That's it. It said write 3 terms, right? Write the first 3 terms, and then the next part would be turn this into an explicit. Y equals, what does it start with? 16 times the decay factor to the x. So that's how we go. It's a quite simple jump. It's a simple jump from recursive to explicit. This is our U0, now known as A. This is the old R, now known as B. A, B to the x. Okay, I'm not going to do part B. Let's move on to step 3. These you're just writing out the first 3 terms and then coming up with the recursive formula. So just plug in 0, 1, and 2. What's f of 0? What do you get when you take 125 times something to the 0? No, something to the 0 is 1. And we're going to talk about that tomorrow, why something to the 0 is 1. We're going to prove it. We're going to prove why something to the 0 is 1. So what's 125 times 1? What's 125 times 1? 125, right? How much change occurred to 125 for it to stay at 125? None, right? There was no change. We plugged in 0. What do you get when you plug in 1? 125 times 0.6. What do you get when you do f of 2? 125 times 0.6 to the 2. 45. The recursive formula would go something like this. You start with 125. Your next term is your previous times 0.6. What percent is this losing every time? 40. It's retaining 60, so it's losing 40. Now, we have to get to part 4. Sometimes they're just going to tell you, you went from 48 to 36. What's the ratio? Take the second term divided by the first term. That's your common ratio. What do you get when you take 36 divided by 48? What did you get? 0.75. 0.75 would be the amount that you retained. The follow-up question that I'm going to underline in blue is, what percent did it go down by? Well, if you're keeping 75%, what percent decrease is it? 25% decay.